Good afternoon, Rich Nass, Executive Vice President with Open Systems Media, here with Dustin Seetoo. He is a director at Premio, and we're going to have a conversation here today about two things that don't always go together, although they should: edge computing, rugged computing. We talk a lot about them both separately, but they really do belong together in many applications. So, Dustin, am I saying that right? Is that really what we're going to talk about?
Yeah, really. I think edge computing is very broad in terms of the technology involved. But really where we're starting to see a demand is as these applications really are specific and dedicated to the application workload and what we're trying to achieve from a result, you're starting to see purpose-built hardware that is being designed by engineers to be reliable and deployed in mission-critical IoT applications. So yeah, rugged edge computing is the theme that we are pushing into 2021.
When you say applications, what specifically are you referring to?
Yeah, so that's a great question. So a lot of the applications that we're seeing specifically in edge computing are requiring some level of intelligence and level of real-time processing that requires storage. So when I say applications, we're starting to see a lot of applications move into the intelligence of robotics, industrial automation, security and surveillance, right, is another big one. Also, I would say the level of autonomous data aggregation in public transportation vehicles or truck fleeting as well. It's really about at a stage of aggregating that data, computing that data, and pushing it into a better machine learning model for more intelligence for a lot of these applications, smart applications, so to speak. Yeah, so thank you, Rich and Embedded Computing Design, for allowing me the time to really drive, kind of a marketing message, and that message really being is rugged edge computing. So, like you mentioned, it's really about coming up and designing these ruggedized, purpose-built hardwares that are being deployed with these machine learning algorithms to really deliver a level of real-time processing and intelligence closer to where data is being generated, right? So. Sorry about that. Go to the next slide. So I think one good place to really kind of segue into and kind of talk about is to really identify some of the key trends that currently have been experienced, I would say, in the last 5 to 10 years specifically, right? So I would like to start at that number one trend, which was IoT. So I know back in the day, IoT was all about the data being deployed from a lot of these endpoints and sensors, and that data is very important. But really at that time, I think the interoperability from all these data wasn't really there. So I think with IoT continuously being able to grow and all these endpoints coming alive, we're starting to reach a level of equilibrium in the sense of technology. And when I say the level of equilibrium, it's really not about technologies at a place that we're comfortable with, but I think it's more about the equilibrium of now this data being able to connect into a lot of these big data analytics, where you're able to compute that data, move it into the cloud, have the resources to actually drive where we are currently in the market, where is the intelligence level, right? So that intelligence level is really being driven by a lot of these purpose-built hardware that can really deliver the machine learning and the intelligence as you move out to the network edge. So that cherry on top really, and what's really kind of the equilibrium of technology continuously would be, I would say, the 5G networks. So, everyone's familiar with 5G networks as they continue to come online, but, 5G networks as a whole is going to kind of culminate all this ultra low latency connectivity and really deliver a level of intelligence, real-time processing for a lot of the IoT sensors, these edge computers, all the way out into the cloud. So kind of segue into a lot of that and what I've mentioned in terms of trends. Most importantly, I think data is what's driving all that, and what data is doing is really delivering more and more data at the edge. So this infographic or this information was pulled from an IDC article that I read religiously for kind of all the data that's being researched about. But basically what it's saying is that as these endpoints come alive and then there's more and more edge compute, you're starting to get more and more of this data, and that data is going to explode, right? So by the year 2025, you're going to see almost 175 zettabytes of data. So that's kind of, in a sense, 175 zettabytes, if you put that into kind of visual terms, you would have kind of like a DVDs that would go around the world like 200 and something times, which is incredible amounts of data. But another interesting fact is that you're starting to really start to see a lot of this data being computed outside of the cloud and move into an edge network. So when you move all that data into an edge network or closer to where the data is being generated, you're starting to see a level of more intelligence, right? And once you have these algorithms doing a little bit more compute closer to endpoints, you're going to achieve better business decisions, better business insights, and really prevent a lot of become more operationally efficient. So I'm sure you are familiar with a lot of the different edge compute models, but most importantly, it's really how the data is being generated, but how it moves back and forth in terms of the workflow. So very simply, you have device data that's being generated from these endpoints, and then that's being pushed into an inference machine learning model, right, that has the intelligent insights. But once you're able to have that level of intelligence, then you move into an ability for better strategic actions. So really, the model of edge computing is what we're starting to see is that this purpose-built hardware working with a lot of the software, connected into these IoT devices, with aggregating all this limitless data sets and being pushed into machine learning models for incredible amounts of intelligence. So that's one of the kind of key benefits of how the edge computing model continuously works. So one thing I think that's important and kind of culminating in terms of all the different technology and moving a lot of this data closer to where data is being closer to where the data endpoints are being generated. What I've kind of classified and what I've seen is that a lot of the embedded world has flown under the radar because of the cloud computing hype over the last 10 years. So what really, I think now what edge computing is starting to move into is that embedded computing really kind of gets its own sexy makeover. And that sexy makeover is now what rugged edge computing is, right? Because you now have all this convergence of all this IoT technology, whether it be, multi-core, small nanometer compute, high performance storage, connectivity, and then lastly, the ruggedization of these products in a lot of these remote and mobile harsh environments is really going to define an area and opportunity for a lot of these hardware products. Second, once you have a lot of these, decentralized local compute power and you have the ability for real-time processing and connectivity, this is what's going to really drive, like I've mentioned, the incredible insights, the business intelligence, and ultimately artificial intelligence for with incredible speed and accuracy. So where does Premio really position its products in this model of rugged edge computing? So really, in a lot of our engineering design, we focus on a lot of passive cooling that's fanless and ruggedized, and they're essentially industrial computers that are been tested and validated to deliver mission critical reliability and stability in a lot of these applications or IoT applications that I've mentioned prior. And then kind of last but not least, how we build upon that and how we drive that is through our dedicated computing roadmap, and it's built off of Intel's x86 architecture on the IoT side, and that really helps us open our portfolio of products, whether it can be in the rugged edge space, a lot of IoT gateways, industrial computers, and last but not least, rugged edge computers. So, I mean, one thing I would like to kind of address as well is, what are the transformative driving factors in edge computing and kind of, in the data flow of, from the core all the way out to the endpoint. So it's very clear that, number one of the key driving factors is the ability for ultra low latency. Once you have the ability for ultra low latency, by definition, you have faster time to actually compute the data, and you don't need to rely on the cloud to go back and forth for the decision making. Second, with another driving factor in edge computing is that you have increased bandwidth. So, bandwidth, you have a bigger pipe to really deliver the data closer to where the data is being generated. And then a third point that's kind of driving edge computing is the level of security. So, I mean, security, once you're interacting with data and data aggregation is very important. So as long as you're able, from a hardware standpoint, able to kind of encrypt that data and protect that data through what we use is just a standard trusted platform module, right? And that's able to be kind of protect the data in terms of from a cybersecurity standpoint. And then last but not least, the wireless connectivity standpoint, right? You have faster wireless connectivity in these new Wi-Fi protocols, so Wi-Fi 6, right? And then 5G, like I mentioned. So, ultimately you have this symbiotic workload balance that originates from the IoT endpoint to the edge and to the cloud, back and forth, working all together based on the application itself. So the last slide for the overall trends is it's cool to talk about all the different technologies and all the driving factors, but I think the key takeaway is to really truly understand the business benefits. So the number one first business benefit, I think, with a lot of edge computing models and the goal of a lot of business enterprises and organizations is to reach a level of intelligence everywhere. So once you're trying to deploy these inference algorithms and deploy in these applications with intelligence, is that you can now specifically target models for better knowledge. You can make better decisions, and then now you can have these different applications out in different ecosystems that are really becoming smarter with more and more data. The second business benefit would be you're able to now leverage the edge and move compute power closer to where data is being generated. So what I'm going to start to see is, I think what we're going to start to see is whether it's being deployed closer to the endpoint, which would be, I would say, like mini nodes or like mini data centers that can interact with the data a lot more efficiently and a lot more quickly, rather than going all the way back to the cloud. And the last but not least, I think what a lot of the business organizations and the enterprises are striving for is a level of full autonomy. So once you have a level of full autonomy and once you have control of that data, that's when you really have an ability to really scale your business or become more operationally efficient and really get to a level of automation. So one of the main purposes of the showcase was to introduce a product that we're launching at Embedded World, which is our BCO 2000 series. And it's a fanless mini computer, and it's really targeted for a lot of these newer edge computing type of applications that require robust compute power. So moving forward, some of the overview of what I'm going to identify is some of the background of the products. I'm going to speak to some of the target markets that the product fits into, and overall the key benefits and features of the products itself. So the reason why the BCO 2000 series is so beneficial for a lot of the industrial applications and the rugged applications is that it packs incredible performance because it uses an Intel Mobile U processor and SoC design, and it's basically low TDP. So you're getting pretty robust processing power in a very small form factor. Second, it actually does address the gap of industrial grade compact PC and low TDP for a lot of the space limiting IoT deployments. And then last, in terms of the overall applications that this product will fit into, you have your manufacturing and industrial automation, security and surveillance, outdoor kiosks and retail, and IoT gateways for edge data connectivity and telemetry. So like I mentioned, kind of what's driving this product at its core is a small industrial grade 3.5-inch SBC. So you might wonder and ask, why we're using a 3.5-inch form factor for the product itself. Is there are some key advantages of an SBC. So traditionally 3.5-inch SBCs are used for a lot of the space limiting IoT applications that require a level of processing, storage, and connectivity. But traditionally, 3.5 inches is a perfect size in terms of putting enough I/O onto the physical PCB, but also offering an ability for deploying these in a range of industrial applications. But some of the disadvantages of a 3.5-inch SBC is that once you use this board, you really have to have an understanding of the hardware knowledge for the final system integration to connect to other peripherals. So in our research, in our overall addressable market competitiveness, we've realized is that a lot of the competitors that use a 3.5-inch SBC really only offer a fixed I/O option for a lot of the boards and the products. So many of the SBCs are integrated into even just standard off-the-shelf chassis that really don't define it as an true industrial grade product itself. So like I mentioned, in terms of the addressable market gaps and kind of the key differentiator of the BCO 2000 fanless mini computer is that it's not deployed with just fixed IOs. What we've identified is an ability for the customer, the end user, to really become flexible and scalable in the specific IO module. So as you can see, it's no longer based on 3.5 inch ports or IOs that are available. You really now have these IO slots that can be deployed through kits, basically dependent upon the application. So if you need to connect a variety of IoT sensors, we have kits available that can actually increase the IO and give the flexibility. So whether it be 4 additional LAN, through RJ45 kits, even a PoE for a lot of powering a lot of these, cameras for surveillance, additional, serial COM ports, right, that we can pull from the motherboard, and additionally, USB ports from a digital standpoint for these IoT sensors as well. So what I'll do is I'm going to show a quick video. So going back to the presentation. So what are the key markets that the BCO 2000 and fanless mini computer can fit into? So the first target market that I would like to discuss is the industrial and factory automation. So in this market, what are the demands that really are driving a product like this? So I mean, in Industry 4.0, there are requirements for smaller, faster computers that can be used for a lot more, workload consolidation, specifically in, data processing, storage, and some type of connectivity. But in lots of times in these industrial applications, oftentimes do face environmental challenges. So, whether that be extreme temperatures, shock and vibration, this product has been tested and validated to kind of accommodate the reliability in those type of environments. And then last but not least, a demand is that, when you're looking to automate and move into more streamlined automation, it does require a level of high performance, in the CPU that can process the complex workloads with, minimum latency. So for this market, the value proposition is that this product does have a fanless design that increases for better reliability. It does use high performance, low power in Intel's 8th gen mobile SoC, which is only 15 watts TDP. And then last but not least, it has flexible IO options that you can pick and choose in terms of the IO requirements that you need for this market. A second market that we see this product fitting into is smart security and surveillance. So a lot of the smart IoT devices and cameras that are being deployed in these remote and mobile applications do require smaller and more ruggedized computers to help process or interact with the security footage. So computers that have been ruggedized can be used for the data processing, storage, connectivity, and pushing into the cloud if needed for further surveillance analytics. And then last but not least, the demand is that as you move into these newer applications that require more smart city and intelligent transport applications, you really do experience environmental challenges. So wide temperature, shock and vibration are some of the demands. So the value proposition for this market is fanless design, better reliability, you have high performance and low power SoC. And then last but not least is in the flexible IO options in a small ruggedized form factor, you do have the ability for PoE to power another type of a smart sensor or a camera through power over Ethernet. A third target market would be the kiosk and retail market. So if on the kiosk side of it, on the back end, there usually is some type of ruggedized computer that's driving a lot of the functionality of the kiosk. And there are a lot of IoT sensors connected to a kiosk. So whether that be camera, payment readers, scanners, these are the type of things that are connected, whether it be through USB digital or even through traditional serial ports or analog. So these rugged computers are used in kiosk environments for a lot of the data processing, storage, connectivity that moves back and forth, based on the data itself. And then kiosks oftentimes are deployed in outdoor environments that do experience wider temperatures specifically. So, having a ruggedized box that has that's been tested and validated is a great option for this market. So value proposition is, fanless design, better reliability, high performance, low power. And then, last but not least is the flexible module kits that you can scale with that type of market. Last but not least, market would be the IoT sensors and data telemetry. So the demand is, as more and more sensors are coming online, like I mentioned, edge compute is shifting a lot of this processing power closer to where data is being generated. So when you do have a fanless mini PC, it can be used as an IoT gateway that can process data, store data, and connect it into the cloud. So gateways are usually deployed in environments where, if it's a remote or if there's some type of harsh environment, the wide temperature feature is great for this market itself. So, value proposition, again, fanless design, better reliability, high performance, low power, right, in 8th gen mobile U SoC. And then having the ability for wireless connectivity through Wi-Fi and cellular LTE is huge for leveraging this type of product for data telemetry. So my last slide, and just to recap, and some major takeaways on the BCO 2000 fanless mini PC. Like I mentioned, it uses a industrial grade 3.5-inch SBC. So it's a mobile U processor SoC design, and it's multi-core, quad-core, 15 watts TDP that delivers incredible performance. Moving to the right of the screen, the overall size of the product is extremely small, compact, and it's pretty robust in terms of power performance. So you do have a small form factor to deploy in a very, very small type spaces. So the product is palm size, and it does have a small footprint. And then moving to the bottom left of the screen, one thing that's a key differentiator of this product, and what most competitors on the market do not have, is that IOs are not fixed. So you do have the ability to maximize and scale your IO options, dependent upon your IoT requirements, through off-the-shelf IO module kits specifically for the product, as I explained before. And then moving to the right is the ruggedization of the product. Why the ruggedization of the product is important, because once it's a fanless design, it has better reliability, and the product itself is tested and validated for wide operating temperatures from -20 to 60 C, from shock in terms of 20 G, and then vibration is 3 GRMS.
Very good, Dustin. Where would somebody go to get more information about the product?
Yeah, so you can visit Premio at our website, which is www.premioinc.com. We have a lot of different resources, whether it be product briefs, data sheets, case studies, and white papers to really kind of showcase how we're helping our customers succeed.
Very good. Thank you very much, Dustin.